In this session, we will take a look at another concept of number theory, that is how to find the sum and product of divisors. In the previous session, we found out how to calculate the number of divisors. So here we will calculate the sum and product of those divisors. Let's get started. So how to obtain the sum of divisors of a given number? Now you would remember that in the last session we had taken a number 48 and factorized the number as 2 to the power 4 into 3. And you would also remember that each divisor of a given number is formed by using the prime numbers available or the prime factors available of that number. And in this case we have 4 number of 2's and 1 number of 3's. So any divisor of 48 will be calculated by using these 4 2's and the 1 3 that is available. And how did we go about it? Every divisor can be formed when we select either a 0 2. 0 2's means we don't select a 2 and we represent that by 2 to the power 0 or 2 to the power 1 or 2 to the power 2. Here 2 to the power 1 represents that we have selected only 1 2 out of the available 4, or 2 to the power 2, which represents that we have selected 2 2's from the available 4 2's. And similarly we have 2 to the power 3 and 2 to the power 4. So the first bracket represents that for getting one divisor we have 5 choices of selecting 2. Either we don't select a 2 represented by 2 to the power 0, or we select 1 2 represented by 2 to the power 1, and similarly 2 to the power 2, 2 to the power 3 or 2 to the power 4. And we also have to select a 3. So and we select either 0 3's or we select 1 3. And on replacing the OR by an addition sign and by the multiplication sign, we get the following expression: 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 plus 2 to the power 4 into 3 to the power 0 plus 3 to the power 1. If you expand that expression, if you expand this expression, in fact you should take up a copy and try to expand this expression, and you will find that every term of the expansion will be one divisor. And once you recognize that, you will appreciate that it is not just a term, every term is not just one divisor, but the expansion of this expression also gives you the sum of divisors. So the expansion of the expression should provide us with the sum of divisors. You will notice that the first bracket is a GP with a common ratio of 2 and the first term as 1. So you see 2 to the power 0, you multiply this by 2, you will get 2 to the power 1. You multiply the second term of the first bracket by 2, you will get 2 square, then you will get 2 cube and 2 to the power 4 and so on. Similarly, the second bracket is a GP with a common ratio of 3 and the first term as 1. So if you know how to calculate the sum of a GP, you will be able to calculate the sum of all the divisors of a given number. Let us see how. So the sum of the first bracket will be the sum of this GP from 2 to the power 0 till 2 to the power 4. And what is the sum of this GP? 2 to the power 5 minus 1 upon 2 minus 1. You would appreciate that if this GP went on till n terms, then the sum would have been 2 to the power n plus 1 upon 2 minus 1. Similarly, here in the second bracket the number of terms is just 1, so n is equal to 1. So the sum of this GP is 3 to the power 2 minus 1 upon 3 minus 1. And if we simplify this, the first bracket will yield a 31, that is 2 to the power 5 minus 1 upon 2 minus 1 will give us a 31. And the second bracket, that is 3 square minus 1 upon 3 minus 1 will give us a 4. If you multiply, you will get 124 as the answer. So let us generalize this. On generalizing, if we have n as an integer which is greater than 1, then the first step is always prime factorize. To find the sum of divisors, the first step will be prime factorize n as a to the power p into p to the power q into c to the power r and so on. ABC are prime factors and PQR are natural powers of these prime factors. So sum of divisors S is given by a to the power p plus 1 minus 1 upon a minus 1 into b to the power q plus 1 minus 1 upon b minus 1 into c to the power r plus 1 minus 1 upon c minus 1. You will appreciate here that the first bracket is nothing but the sum of GP from a to the power 0 to a to the power p. The second bracket is nothing but sum of a geometric progression from b to the power 0 to b to the power q. And the third bracket is nothing but the sum of a GP from c to the power 0 to c to the power r. And this is a generalization for the sum of divisors. Let us apply this expression, let us apply this formula to calculate the sum of divisors of a number. Find the sum of divisors of the number 240. So the first step, we prime factorize. 240 can be prime factorized as 2 to the power 4 into 3 into 5. So the first bracket will be 2 to the power p plus 1, that is 2 to the power 5 minus 1 upon 2 minus 1. The second bracket should be 3 square minus 1 upon 3 minus 1. And the third bracket will be 5 square minus 1 upon 5 minus 1. We've just substituted these values in the appropriate formula. On simplifying, the first bracket will be 31, the second bracket will simplify to 4, and the third bracket above will simplify to 6. And this will yield a sum of 744, which means all the divisors of the number 240 will add up to 744. Now, how to obtain the product of divisors of a given number? Can we generalize, or can we arrive at some general formula for the product of divisors also? Let us see that. Again, 48 is equal to 2 to the power 4 into 3. This is the prime factorization of the number 48. If we note down all the divisors, we have 1, 2, 3, 4, 6, 8, 12, 16, 24 and 48 as all the divisors of the number 48. Now let us see, let us take the first divisor 1 and the last divisor 48. What is the product? The product is 48. Then let us take the second divisor 2 and the second last divisor 24 and calculate the product. The product is again 48. Similarly, if you take the third divisor 3 and the third last divisor 16, you will get the product again as 48. In the same way, if we keep on forming pairs, the fourth and the fourth last number or divisor will give us another product 48, and the fifth and the fifth last divisor will again give us a product of 48. So there are 10 divisors which we have formulated, which we have rearranged, reorganized into 10 pairs, and each pair gives us a product of 48. And there are 5 such pairs. So the product of divisors is equal to, the product of divisors is dependent on the number of such pairs that can be formed. So if you multiply 1 into 2 into 3 into 4, 6, 8, 12, 16, 24 and 48, you will get the answer as 48 to the power of 6. So the product of divisors depends on the number of such pairs that can be formed, and the number of pairs is nothing but number of divisors divided by 2. Obviously, if the number of divisors in this case is 10, therefore we got 5 pairs of divisors such that their product of each pair is 48. On generalizing, the product of divisors is given by the number n raised to the power of d by 2, where d is the number of divisors of the number n. So what is the first step? To calculate the product of divisors, the first step is factorize the number n. The second step is find the number of divisors of n, and the third step is apply the formula. The product of divisors is equal to the number n raised to the power of d by 2, as we saw in the last slide, where d is the number of divisors. So let us find the product of divisors of the number 72. 72 can be prime factorized as 2 cube into 3 square, and on applying the formula for number of divisors, the number of divisors will be 3 plus 1 into 2 plus 1, which is equal to 12. You should remember the formula for number of divisors from the previous session. Once we get the number of divisors as 12, the product of divisors of the number 72 will be equal to 72 raised to the power of 12 divided by 2. Remember, if the number of divisors are 12, the number of pairs that can be formed which yield a product of 72 will be half of 12, that is 6. So the product of divisors of 72 is equal to 72 raised to the power of 12 by 2, that is equal to 72 to the power of 6. So with this we come to an end of this session. In case you have any feedback or in case you have any query, please feel free to write us at studentservices@pfindia.com. Thank you very much.